Well, we're back here in the office now. We wrapped up day 2 successfully. We were able to complete the third of the final 3 missions at the north end of the property from the South Florida Water Management District Canal back into our heavily vegetated north end. When we got back to the office yesterday, we unloaded our truck. We were able to bring in all of our batteries and recharge our laser and drone batteries. We then compiled all of our laser data on the USB along with our ground control points off of our data collector, and then we can import those into our SSD on our processing machine, where we can then begin importing all of the cycles directly into GeoQ LP360.
So what we're going to do today is we're going to upload everything into LP360. We're going to make sure that all of our files are correct and the accurate measurements are there. We're going to load our GCPs and then deliver the files to our project managers.
So now that we're back at the office, we have plugged in our USB drive into our computer, and we will begin transferring our files. So as you can see here, the bottom 2/3 is day 1. So we started here at the very south end, we moved further north to the middle of the project, and then on day 2 we completed the northern third up here next to the adjacent canal and highway right-of-ways. Once we begin importing all of these cycles, we'll be able to begin processing them individually, and we will work, like I mentioned, from left to right, starting with POSPAC processing. We will then analyze and create our flight lines. We'll be able to turn those flight lines into TrueView trajectories, and then last but not least, we'll be able to geocode the LiDAR, which gives us this beautiful RGB LAS point cloud that you see here on the screen on the left and right in 2D and 3D. As you can see here, we have all of our individual cycles here. Once we have completed processing from left to right through POSPAC, flight lines, and geocoding the LiDAR of each individual cycle, we will then combine all of those LASs into one single LAS. So what you can see here as I turn this on, we now have one single LAS file of the entire project. Now that we have completed the classification and quality control process, we are ready to move on to the deliverable phase. What we'll want to do is take our LiDAR point cloud and we are going to extract a contour surface. So LP360 makes this extremely easy. It can go ahead and do a couple hundred acres in a minute or 2. Alrighty folks, now that we have exported our surface, what we'll do is we will bring that surface over to CAD and import it. What you see here is the imported surface from LP360 in AutoCAD Civil 3D. Zooming in here in CAD, we can see we've got some pyramiding that may or may not be accurate. We can verify that this is incorrect by hovering over this outside area and getting an elevation of 15 feet. And we can check inside the elevation, 57 feet. We don't have any ground that's 57 feet, so we know this is vegetation that needs to be unclassified. And what we'll do is go back to LP360 and zoom into that area. So we'll draw a profile across that area, encompass the whole piece. And as you can see here on the 2D profile view in the bottom window, we've got a point way up high in the air here. And we'll use these 2 tools here, which is classify points above the line, and we will draw in a line. And you'll see that as I draw that line, that little point down there turns from yellow to white. That means it's been activated. After we have our line, we'll hit spacebar, and that activates that point to become created, never classified again. And it disappears. As you can see up here, our pyramiding has also disappeared up here. And we'll do the same thing across the entire project, going through, looking for inconsistencies between CAD and LP360. Once we are satisfied with the quality of our surface, and then we'll be ready to import our orthomosaic for placement underneath of our surface. So we'll import it, and you'll see it snaps right to where it's supposed to be. You click OK. And then all we need to do is just send our orthomosaic to the back. And then here you can see your surface on top of your orthomosaic. And you'll want to, again, do a little more quality control and just make sure that your contour lines match up with what you're seeing in the orthomosaic. So once we have everything in CAD, we're ready to save our entire project and pass it off to our project manager. In conclusion, this is what we will end up with as a final deliverable. And as you can see, we were able to generate an extremely high definition orthomosaic photo, which allows you to zoom in and almost read someone's license plate from 250 feet in the air. It's pretty good. And then in addition to the orthophoto, we were able to generate a ground surface LAS point cloud that contained upwards of 70 million points across some 600 or 700 acres, which is just almost infinitely more than you would ever be able to gather with a traditional GPS field crew in a fraction of the time. To do a heavily, densely vegetated area with marsh wetlands would take weeks with a traditional field crew or multiple field crews. Whereas in comparison, our UAS operations department was able to use the TrueView 635 in conjunction with LP360 to complete a 600 to 700 acre topographic survey in a matter of 2 to 3 days, including planning, operations, processing, and deliverables.